Hello dear students, again we'll discuss some more numerical problems based on the topic or a concept we have already discussed in the previous class. So it will be helpful to understand how we can solve the problems by understanding the question itself. Let us move ahead with that. It's written on the board here, one question that is very interesting here. A particle executes a simple harmonic motion of a time period 12 seconds. After 2 seconds, it passes through the center of oscillation. The velocity is found to be 3.142 centimeter per second. The amplitude of oscillation is, they are given 4 options: 6 centimeter, 3 centimeter, 24 centimeter and 12 centimeter. So before going to the solution here, we need to understand the problems first very clearly. Particle executes the simple harmonic motion. Simple harmonic motion means we know that it is executing to and fro motion. It is from mean position to one extreme position, again extreme position to mean position to another extreme position, another extreme position to the mean position. That means which point body start executing simple harmonic motion, from that it starts the journey and coming back to its original position where it has started the simple harmonic motion. Whether body may be at the mean position or body may be at the extreme position, doesn't matter, but particle executing simple harmonic motion does not say. But when particle execute the simple harmonic motion, I'll take out from the mean position only, moving from extreme position to mean position to extreme of next negative and coming back to its original position. So 1, 2 and fro motion completes the one oscillation. So that time period it is given as a 12 seconds. So after 2 seconds, it passes through the center of oscillation. Nothing but the, if it is executing simple harmonic motion, so from here to here it is. So 2 seconds, here it is very meaningful question they have asked. After 2 seconds means after one oscillation. So 2 motion it is taking 1 second, another flow motion it is taking another 1 second. After 2 second mean after one oscillation it's crossing the center of oscillation. So it is crossing the center of oscillation. So we need to find out from extreme position to the center of oscillation, that is nothing but an amplitude. So amplitude of oscillation is, we need to find out. So this position we need to find out. Velocity, well, the journey of extreme position to the crossing the center of oscillation, or total velocity of a particle executing simple harmonic motion. It's already given. So 3.142. So only thing that we need to find out the amplitude of the particle here. So let us go ahead with this solution. So options you have to remember here while solving. Which answer we are getting, that is very important, because the board is very inconvenient to keep the option, question and solution. So I have redated the question, given the option also, explain the how it is executing. Now let us move ahead with the final part, that is of solution here. So aside I'll write the option here once again. So option is given, first option it is, that is of 6 centimeter, that is of 6 centimeter. First option it is a 6 centimeter, second option it is 3 centimeter, third option is a 24 centimeter, fourth option it is 12 centimeter. So these are the options of amplitude, right? So what are the given things? Let us go ahead with the solution part. So velocity it is given, that is of 3.142 centimeter per second it is given. So time period it is 12 seconds. T is equal to 2 seconds. After 2 seconds it is, after 2 seconds it passes through center of oscillation. Center of oscillation, which is given in the question, no? So let us go ahead. So these are the given data in the question here. So we have the displacement x is equal to a sine omega t here. So here you need to understand which form of the displacement, which form of the velocity and acceleration relevant to that problem we have to select here. What is the general equation? A sine omega t plus phi it is. But I have not taken the phi here because particle executes the simple harmonic motion at the mean position at t is equal to 0. Then phi is also 0. Means it is not making any angle. So if phi is 0 means it will be remains with only this form. Right. So it is considered as a sine omega t here, as velocity is a dx by dt. We got it, velocity is a omega cos omega t it is after derivative of the displacement. So a omega cos omega t here. At t we have a relation 2 pi by omega here, right? So this part omega in the, we can write it omega is equal to 2 pi by t here, right? 2 pi by t. So in place of omega we'll substitute this one. So what we are getting here? So we are getting velocity is equal to, a will be same, omega in terms of omega I'm going to write it here 2 pi by t cos of 2 pi by t into t here, right, where t is given as a 2 seconds. So let us given data here, t is given 2 seconds, capital T is 12 seconds, and velocity is given here. So velocity, in place of velocity I'm going to write it, it's a given value 3.142. A is not given, that only we are going to find out here. So 2 pi by t is 12. So cos of 2 pi by 12 into 2 here. So after doing all this calculation, so we'll get the amplitude value here. 2 ones are 2 6 are 2 ones are 2 3s are here. So cos pi by 3 here, then 2 ones are 2 6s are. So a pi by 6 cos pi by 3 here, right? So this is of 3.142. Totally a we are getting 12 centimeter. So this is of amplitude of the particle. If you go ahead with the simple calculation here, you will get to know that what is the amplitude value. So directly I have written here, if you go ahead with this simplification of this step, you will get the 12 centimeter. So option is D. So how to solve, that is very important here. Last final answers, definitely you will get it as one of the option only. So that doesn't mean that all questions are having the same and the correct answer. There are some questions maybe it is wrong. Just assumption is very important, and sometimes solution is plays a very important role than the option here. So we'll go ahead with some more problems, right? So in that we need to find out the displacement of a particle in a particular given value, that is particle executing the simple harmonic motion with an amplitude 5 centimeters. So question is there here, that is of I think 7th question it is, or whatever it is, which how many questions we have solved. Particle executing simple harmonic motion with an amplitude A is equal to 5 centimeter here. Orally I'm saying the question, sometimes it may catch, Sometimes it may not catch while writing. Just concentrate on the y's also, that is very important. 5 centimeter and the time period, it is of 0.25 seconds. Velocity and the acceleration of particle. Velocity and the acceleration of particle. It is not short form here, velocity and the acceleration. Full sentence is there, but inconvenient of a board here, I'm writing a short note on here. I mean to say that short letters. By seeing this, you can understand this is the velocity and the acceleration here of particle when displacement is 5 centimeter. So options are given here. First option is 0.5 pi meter per second here. Second option is 0.5 meter per second. Wait. In the first option, displacement, velocity and acceleration. This is acceleration. Sorry, velocity, and this is of acceleration. 0 meter per second square. I'll write it the option here. So 0.5 meter per second minus 5 pi square omega meter per second square. Third option is 0 meter per second minus 5 pi square meter per second square. Sorry, meter per second square, meter per second square. Third, last option it is 0.5 pi meter per second minus 0.5 pi square meter per second square. So this is a bit difficult feels, but it is not difficult. It is very simple also. The thing is that I'm not going to erase the option here. Let it be here. We'll go ahead with the solution. A particle executing a simple harmonic motion with an amplitude A is equal to 5 centimeter and the time period is a 0.25 second. We need to find out the velocity and the acceleration when displacement is at the 5 centimeter. So meaning itself is a simple. If you can go ahead with the diagrammatic form, we'll get to know that particle executing the simple harmonic motion, right, with an amplitude. So amplitude is a 5 centimeter here, where it is there at the particular point now. So I'm going to write it here at the extreme position. Amplitude is at the 5 centimeter and time period it is given, that is of 0.25 seconds it is to complete the simple harmonic motion, and we need to find out the velocity and the acceleration. Displacement is also nothing but the x is equal to 5 centimeter only. To make us a confusion, they had given amplitude as well as the displacement here. So let us go ahead with the solution. As we know here, velocity form is, I said, in which form for the particular problem we have to select. We know that velocity is equal to omega is square of a square minus x square. This form is also we have discussed in the previous class. We have velocity is equal to what here? A omega cos omega t plus phi also we have. A omega is also we have. So these are the very important form of the velocities. So it is depending upon the problem which one we have to utilize to solve the problem. Here amplitude is given, displacement is also given. Only thing that we need to find out the velocity here. No need to use these all things. So depending upon the given data also, we need to frame which form we have to apply for the finding given task. So that's why I'm using velocity v is equal to omega root of a square minus x square. So velocity omega, we have a relations with the time period, that is of 2 pi by omega. So omega is equal to 2 pi by t here. That means 2 pi by t is what here? 0.25 second. So 0.25 second, 0.25 or 0.22. Okay. So this will give you, that is of 10 radian per second. So I'll write it here, 10 radian per second it is. So in place of time period it is given, you have to substitute and find out the omega value here. So that is of 10 radian, 10 radian per second here. Root of a square is also 5 square, x is also 5 square. So totally we are getting 0 here. Velocity is 0. Velocity is a 0 means what? Velocity is at the extreme position. I think you are getting the point now. Velocity, we got it here, 0. That means particle is at the extreme position. Which extreme position it is not given in the question. Either it is a negative extreme position or the positive extreme position. But we have to assume it as particle is at the positive only, because it's easy to solve, easy to understand in which part particle is there, right? So if particularly they had given the positive direction and the negative direction, and at that time you need to understand and frame the diagram with a convenient form of the equation. When it is not given positive and negative, consider that particle is moving in a positive only. Then we'll get the conclusion where is the particle and what is the expected velocity and its acceleration. We'll solve it very easily. Okay, we got it here, velocity is equal to 0. Next is what? Acceleration. So we have acceleration form, that is of minus a is equal to minus omega square x it is, right? So I'll write it here form. Omega is equal to, this is not there, this is a problem. Solution minus omega square x. Omega we got it here how much? 10 pi radian per second. So 10 pi radian per second here. I will write it minus 10 pi radian per second whole square. X is 5 here. So 5 means what here? 0.05. How we got it? This, because centimeter is there, no? If you go ahead with the meter form, because displacement is given in centimeter, amplitude is also given in centimeter, but in the option it is given in terms of meter. So let us convert it into 5 centimeter into 5 meter. Minus 10 pi radian per second square whole square into 0.05. So 0.05, you will get it here. A is equal to minus 5 pi square radian per second. Here it is meter, no? 5 meter per second. 5 meter per second. Oh, acceleration is meter per second square it is. So acceleration is minus 5 pi square meter per second square. Velocity is 0. So let us go ahead with the which option it is. We'll go ahead with the velocity first. 0 is there. Yes. So in a given option, third option, we are getting velocity as a 0 meter per second, and acceleration is a tally with our got the answer minus 5 pi square meter second square. Very good. So this is the given option here as we got the solution. So those were getting difficulty while solving here, just pause it and cross check, because I have not erased the problem, I have not erased the option here. Just in this small portion only I have explained and have solved the problem here. And the thing is, make the list of the formulas whatever we have discussed here, right? So why madam has taken v is equal to omega root of a square minus x square. I have written a form of velocities also. Three forms of velocity will be there, but all will give you the same velocity of a particle. This equation gives different value, another equation will give different value. No, it is not like that. Velocity is the same, but the direction of to approach the velocity is different. Those all we got it from the derivation we have already done in the previous class. So that you have to make it the list and go for the solution. So now after this we'll go ahead with some more problems that is also very interesting here. Yes, the next problem, it's very interesting. All the problem is interesting only. So let us go ahead with a particle executing simple harmonic motion according to the equation. Equation is given here. X is equal to 5 cos 2 pi t plus pi by 4. The displacement and the acceleration of a particle at a time period t is equal to 1.5 seconds is. The options are given here. That means we need to find out the displacement and the acceleration in this problem. So first option is minus 3 meter 100 meter per second square acceleration, minus 3.5 140 meter per second square acceleration, 2.54 meter and 200 meter per second square acceleration, 3.55 meter and 120 meter per second square acceleration. So first is a displacement, x is there, and second option it is, second form of the same equations, options are given in this acceleration. So that means first we have to find out the displacement. So x is equal to a sine omega t plus phi it is. So this is a not a sine here, a displacement x is equal to a cos omega t plus phi it is. So this is the option, it is this is the general form of the particle executing simple harmonic motion here, a cos omega t plus phi here. So in this form you have to compare, as here amplitude is given as a phi here. You can go ahead with the amplitude is phi, unit is not given, so let it be here. Next form here, according to this equation, displacement at a point at a time t is equal to 1.5. So we can write it here, x of t is equal to 1.5. That means phi cos 2 pi in terms of omega is equal to 2 pi here, right? Omega is equal to 2 pi per second. T is equal to, I'll write it here, t is equal to 1.5 second it is. Now what we are getting, 2 pi into 1.5 plus of 5 by 4 it is. Same equation I'm writing here. So x is equal to, here you have to write it, t is equal to 1.5, because for this time period we are finding the displacement here. So 5 cos 1.5 into 2, you will get it here 3 pi plus pi by 4 here. 5 cos 3 pi plus 5 by 4. So we'll go ahead with the allied form of it, where I have to write here only, I'm going to write it here. So allied form here, 0, 90, 180, 270 and 360 degree here. I think camera is not catching. So let us go ahead with this here only. 0, 180, so 90, 270, 360. So 3 pi means what? 3 into 180. That is of 540 here. How we'll get? So particle is executing, pi it is 2 pi, that is of 360 here, 2 pi it is. Next next it will come here 140, then only we are getting 540 degree it is. It is in the form of what here? So 360 plus 180 degree, you will get it as a 540 degree here. So 360 means what here? 360 means it is of 2 pi. 2 pi plus pi it is. That means whatever we are getting cos in this form, 540 it is. That means cos 180 degree here. That means in the second quadrant, sine is positive, cos is negative here. That's why minus 5 cos of pi by 4 it is. So how we got it here? 3 pi plus pi by 4. 3 pi means what here? 3 into pi, that is of 540 degree it is you are getting. If you go ahead with the angle formation, so 0, 180, 180 to 360, that is of pi here, pi and next pi, 2 pi it becomes, but we have make it as a 3 pi here. That means it is coming one more pi here, that is 3 pi we got it here. 3 pi plus pi by 4. It is in the form of cos 3 pi plus theta, means cos theta. That means 90 plus theta, 180 plus theta, 270 plus theta, like that it is. Cos 360 plus 180, you will get it as a 540 here, or else you can go ahead with the cos. So here it is 540 can be written here this form, that is of 3 pi here. So cos 540 plus theta, cos 540 plus theta, that means what it is? So theta you are getting cos theta, it is in the form of cos theta here, because this is one of the form of allied angle it is. For 540 second quadrant it comes here, that means sine is positive, cos is negative. So cos theta, so cos pi by 4 it is, minus 5 cos pi by 4. So pi by 4 is 1 by root 2. So minus 5 cos pi by 4 is 1 by root 2 here. So 1 by root 2. So what value we are getting here? Minus 3.54 meter. So this is the displacement we got it here. X is equal to what? X is equal to what here? Minus 3.54 meter. I'll write it here. X is equal to minus 3.54 meter. We got it. That is the displacement. We got it here. The next form here, we need to find out the acceleration. So let us go ahead with the acceleration here. At the time period 1.5 second. So we have acceleration minus omega square x it is. As we got omega is what here? Nothing but the 2 pi by t here. That is 2 pi by t is what here? T is it is directly we got it, no, here no need to convert. Omega is what here? 2 pi x, we got it this much. So minus 2 pi square x is what? Minus of 3.54 meter. So we are getting totally 140 meter. So because it is in meter per second square, so second square is there here. So acceleration, minus into minus, it will get positive here. Acceleration we are getting 140 meter per second square. So let us cross check where is the option here. So that is the option here, minus 3.5 meter as a displacement and 140 meter per second square. So option is B. When you go ahead with the first option, its acceleration fails here, and almost displacement is also wrong. Second, third option, not possible. Fourth option may get you trouble. So once you got it here, displacement, you may cross check here. This maybe happens. So once you finally will get the acceleration, you will get to know that which option is the correct one here. So by this, we can conclude here. It is possible to solve the competitive questions by understanding the question given in it and try to frame diagram so that half solution is completed only. The next part is only the giving numerical values for the justice of in the given options. It's not compulsory all the options may be given as a same. It seems to be as a same, but any one will be the correct form. That we need to understand here which form we have to apply to get the correct solution of it. So this will give you solution of the problem.